Hello again, everyone. Okay, this should be the second video, so hopefully you watched the first video, but I will do just a brief recap in the next on the next slide anyway. So no worries if you didn't see the first video, but please feel free to go back because obviously this knowledge continues to build off of each other. Fozzie's here. He's going to help us a little bit more this time. He was snoozing through the last one. I think he's still going to snooze through this one, but he's going to semi-listen. All right, let's dive in. So you should have this at the top of the packet I gave you. This should be the very front page. If you do not have the packet because you were not there on Friday, it is going to be in the back of my room. So if you can, or if you get the chance in the back of the room, make sure you grab this packet. So this is going to be about inscribed angles and inscribed or intercepted arcs. So if you watch the previous video, basically inscribed angle is 1/2 of the intercepted arc when it comes to degrees, which you'll see more when we do some practice problems. Or the opposite is true, that 2 times the inscribed angle equals the intercepted arc. So this is kind of what that looks like. Either way, you should be able to find the answer you're hopefully looking for. Let's see what that looks like. All right, so now we're going to determine angle SBE, or angle B as you will. So we know SE right here, which is 52. And if what we know is correct with the equation that we learned earlier, we just have to do 1/2 times 52, or 52 divided by 2 to find out angle B. So if we do 52 divided by 2, we get that angle B is 26 degrees. All right, now we are going to look for angle OB because there is no BO in geometry except for all the 9th graders. Just kidding. All right, so this time it's the opposite. We know the angle and we want to find the arc. So instead of dividing by 2, we are going to multiply 63 by 2. And then once we do that, we get the angle BO, or OB I should have put, is 126. Hopefully you followed this really well. Hopefully this is clicking really well, because this is a lot of what we're doing. We just might throw in a little bit more algebra, like you'll see on the next slide. All right, so in this problem, we are looking for similar. We are given an arc length of 110. And we want to find the inscribed angle. So we're going to use our formula that 110 times 1/2, or divided by 2, should equal angle D. Or I put IBE, I meant to put IDE. Once you divide by 2, you get 55. All right, now we're doing the opposite. We're looking for TD. And we are given this angle right here. So once we plug those in, instead of dividing by 2, we're going to multiply by 2. And then we get that TD is 76 degrees. All right, let's try another one. This one we are given we are looking for HTA. We are given this arc length of 102. So we can solve for angle A, which is not the angle we are looking for, but once we know A, we can solve for angle T, and hopefully you're following Y. So angle A should be 1/2 of 102, so we get the angle A is 51. So if angle A is 51, and we have a triangle right in here, then angle T is equal to 180, because that's the sum of all angles of a triangle, minus 51 minus 67. So we get that T is 62 degrees. I hope you see how I got that. You have to remember that a triangle adds up to 180. But we get 62. All right. So you'll notice that this one has a star. Well, it has a star because there is certain information that you do not know yet that we are going to be addressing in this example. Do not worry about this till we get to it later, but maybe it will click now and then you'll be set even better when we get to it. So first, we're going to solve for our missing arc length. So we know most of our arc lengths of the circle, and we know that a whole circle adds up to 360. So if we subtract everything we know from 360, we get our remaining angle of KY. So we get that KY is 80 degrees. So here's where things get a little fun. N right here is clearly not a midpoint. And I say clearly because if this angle was exactly halfway, then then the other side would also be 130, but instead it's 80. So there's a very easy solution on how to find angle N. So if it's not 130 and it's not 80, but this angle the vertex makes these sections, then it must be a little off between the two, so we can find out halfway what that would be, and that would be our angle. So this is the new concept that we haven't fully addressed yet, but basically if we take the sum of 80 and 130 and divide it by 2, that should be exactly in the middle between the two where angle N resides. So we get the angle N is 105 degrees. So again, we'll talk about this more when we get to when we get a little bit further into our videos. But once you know this is one of the other ways I was able to solve for every angle in the circle for the first video. All right, let's move on to the next problem. Okay, so here we're looking for l'angle li, or li. We are given the arc length of 60, so we are trying to find this inscribed angle E. Same principle applies. We are going to do half of 60, so we get the angle E is 30 degrees. Same thing that you know how to do with our inscribed angles, but finding the arc length. We are going to do the opposite, 70 times 2. So we get that it is 140 degrees for PT. All right, so again, we are given IJO at 20, or sorry, we are not given IJO, we are given the arc that is 90, and we are solving for IJO. So IJO should be half of the arc, so 90 divided by 2 is 45. So we get that angle is 45 degrees. Now we are doing the opposite. We are given that GIOJ, or angle I, is 20 degrees. So we know that double that should give us GJ. So 20 times 2, we get that it is 40 degrees. All right, so if you have an inscribed angle that intercepts the diameter, really what you have right here is a right triangle. So this angle will become 90 degrees. And they'll usually keep this dot in the center and then keep line segments going to the center. Sometimes you'll also see them use radius. You're still sometimes able to use this and create different right triangles, and then you can use your knowledge of right triangles to solve equations. Well, you probably already know what angle G is going to be, but I just want to reiterate that we know that K to N is halfway around, so 180. So if Kn is 180, then angle G, when it's looking out, we know that angle G is half of 180, so 90 degrees. Well, if it's 90 degrees, then we can set that equal to 6x, and then we can divide 6, and we get that x is 15. All right, so hopefully you remember what I talked about when I said that if they shared the same arc, then the angles should be the same. Because if we look at dy right here, O creates that angle, and so does K. So if we did K times 2, we'd get dy, and if we did dy times 1/2, you'd get O. Or you can just cut the middleman, and you get that O and K are equal. Well, same thing applies for OK right here. OK, or KO, angle D creates that, and so does angle Y. They both create this gap over here. So, again, they're equal. So we can set them equal to each other and solve for x. So 9x plus 18 equals 15x, or 5x plus 15 equals 3x plus 21. So we're going to slowly try to get x by itself. So if you did this first equation, you could subtract 9x on the other side, and you'll get 18x equals 6x. If you did this other equation, bring the 3x over, 15 to the other side, and you get 2x equals 6. Either way, once you divide, you get x equals 3. Now we can use this to solve for our next couple questions. So now we are trying to look for angle YNK. So we are just going to plug in 3, add all these angles up, and all of these angles added together should equal 180. So let's go ahead, and 180 equals 15x plus 3x plus 21 plus angle N, which is what we're looking for. Let's plug in our 3. And then we get this, combine like terms. And then now let's bring the 75 to the other side. And we get that N equals 100. Sorry to end the last slide so abruptly. Hopefully you're able to get the answer. Let's look at this slide. So we have 20 right here. And across from 20 we have RE, which if we look, this angle also makes RE. So we know if this is 20, then this should be 20 because they make the same arc right here. So both should be 20. And now we know that this is 30, EK. So we know that this angle right here should be half of 30. So it should be 15. Well, then if we want to solve for this whole angle, all of angle S right here, then we just need to add those two together. So add 15 and 20, and we get that this angle is 35 degrees. All right. So here's another way you can solve this equation. So we know that H is 20 right here, and then we can look for RE, and we already know EK. So if we did 20 times 2, we get RE is 40. Well, we can then find out RK by adding 30 and 40. So we get that RK is 70. Well, RSK, the angle that we found in the last one and that we're finding again, is half of 70. So there's multiple ways to solve these questions, so find whatever works best for you. All right, so we know that SKA is 74 in this problem right here. And so if you remember, we know that the outside arc length here is 74 because K is a central angle. And again, that's one of the difference in central angles versus inscribed angles. So now that we know that, we can actually solve for NS because we know that N to A is our diameter. So from N to A. So from N to A, it's 180. Well, if we took 74 away, we can find out NS, and we get that NS is 106. And that's important because NS is actually our arc for our inscribed angle of T, which is what we're looking for. And if you remember our rules, that means that angle T should be half of 106. So we get the angle T, or NTS, is 53 degrees. Okay, so now we are going to look at the circle, and we can already tell that these two share arc AB. So angle C and angle D should be equal to each other. So knowing that, we can set them equal to each other to solve for W. And then once we solve for W, we get W is 12. We can plug that in to find the angle for either of these. So plug in 12 and we get 80. Well, now that we know that angle, we can find the arc length that's across from them by doubling 80. And so we get that the arc length is 160 degrees. I sped through that one. Hopefully you're able to pause and kind of take a second to realize what we did each step of the way. I'll try to go slower on some of the next ones. All right, that concludes the second video. By this point, there's probably a quizzes that you can do for inscribed angles. And once you're done with that, hopefully you get 100%. I'll allow multiple attempts. You can then move on to the next video. And I'll see you there.